structured, so I could email you this recording a little later today. And I'm going to move to section 2, right? That's what we were looking at last time. I'm not sure if we had a quiz. So we looked at functions, the name for that special type of relationship between X and Y. So that's a function. This word will be used a lot, and we were able to determine if we have a function or not by looking at vertical lines possible. That's like a vertical line test. So if you find a vertical line that intersects our graph at 2 points or more, that's it. It's not going to be a function. So vertical line test when you have a graph. That's the idea. But as I said, in this class, we'll work with functions, and that's pretty much all we're going to care about here. So we were dealing with also words such as a domain and a range for a function. So we start at domain, we end in the range of the function. In other words, domain is going to be on x-axis because we start on the x-axis and we send from x-axis our values to y-axis. So with various graphs here, if you're thinking about so-called domain, then you are looking at points on the x-axis, and then the graph makes them to correspond to some value on y. So technically the function sends the point from x to point on y-axis. And that's why domain is always going to be on the x-axis. That's where we start. And range is always going to be on the y-axis. So for example, for problem number 36, the domain of this function will be all real numbers. Or in other words, entire x-axis, all values of on the x-axis, we call them as all real numbers or all reals. So let's see, how do I see this? Well, turns out this parabola extends infinitely upwards, and if you go higher and higher, your actual x values could be increased without any restriction. So if there are no restrictions, we say that domain is everything. Now, range will be on the y-axis. So for the range, I'm thinking about all possible y coordinates, and notice that they're only positive. Maybe 0, so I put y, should be careful. Y coordinates are only positive because it's only points with positive y coordinates that I get to when starting domain. I never get anything negative because there is no graph below x-axis. So the range for this particular case is restricted. So words domain and the range you will encounter every once in a while. And I guess I'll keep refreshing those ideas when we need. All we need to know at this stage is domain is set of possible values of x and range is set of possible values of on y. So besides that, we used to graph various functions, and we already did this before. So we remember graph parabolas and lines, and we will continue with this. I also graphed one so-called piecewisely defined function. So that was designed from little pieces. And I told you that's not a standard kind of graph. So since there are some exercises showing you this piecewise functions, well, then you can do one problem again if you want to. But I don't think I'll be asking you to work much with those piecewisely defined functions. So I guess I'm gonna maybe do one exercise. I remember I promised you one exercise last time, one more. So why don't I try problem number 51 to see how to find some values of function which is given to us piecewisely. It doesn't ask us to graph, but it wants us to find two possibilities. F of -1, what it is equal to, and what is f of +1 equal to. So those two functional values. And it turns out when function is given with pieces, there actually looks like 4 different functions that we working with here. And the first thing is to figure out which one of these functions I actually have to use. So for the first part here, where we are looking for f of -1, I'm going to have to use the first piece. The reason is that my function f of x deals with f of -1. So please notice that it's in the first portion here, because the domain of this will be broken into 4 pieces. There are points such as 0 and 4 being involved, and my first portion of function is dealing with everything to the left from 0. And since my value of x is -1, then it is on the first portion. So that's why what I have to do is look at the graph of function y is -1 minus 2x plus 1. So this is the equation that I'm going to utilize for the exercise. And I will plug in -1 instead of x. So we just calculate the values. So I put -1 instead of x right into that equation. Because once you figured out which equation you want to utilize, then you can just plug numbers in and calculate. So that'll be 2, right? -2 times 1, -1 is 2. And when you add 1 to it, you get number 3. So that's for the f of -1. So now the question is, what about +1? Which piece is this on? Well, +1 is to the right from 0, definitely. And this is going to be on a piece which is corresponding to part 3, isn't it? And between 0 and 1. So we're dealing with x squared minus 3 here. So I need to square and then subtract 3. So once I found out which piece we're supposed to use, well, then it's become a straightforward calculation, right? So just plug in this 1 here. So square is still 1, and then you subtract 3 and you get negative number 2. -2 is the result. So yeah, I know that this piecewisely defined functions, you don't see too often, and I guess we may not see it again, but just to see how you can work with them. Because they're functions, and in this class we're learning functions. So that's pretty much all I wanted to mention with regard to section 2 of this review chapter. You know that this special other groups of exercises they have here, synthesis or say, technology connection. So I don't expect you to do this because they're just something that author produced to fit into the just fill more room on the section. And the story of functions and their domains and ranges does not end here. It actually continues in the third section of review chapter. So I'd like to take a look at some of the domains today. And then based on domain, you can talk about range as well. So the key idea, how to find the functional domain or various x coordinates. And that's what they're talking about here, in this section. So they looking at the example 3 at the graph, and they say x coordinates or domain will run from here to here. Those are all possible values of x. That's always on the x-axis that we have for domain. And then for y coordinates, all possibilities looks like will range from the lower to the higher portion. So everything in between of those two values along y-axis, we're going to call as a range. I think they actually have this a little lower here. Yeah. So they're talking about range all the way down on the bottom. So you can see y coordinates, all possibilities that vary from -1 to +4, looks like, are in the range. So if you have a graph, then it's pretty straightforward to see what possible values of x and what possible values for y are. But what if you don't have a graph? Because again, this class is all about producing a graph. So we first decide what domain is, and then we graph, not vice versa. Because here in the exercises, they give you a graph and say, well, asking for domain and range, and it's pretty straightforward. But what if you're not given the graph? Well, it turns out that we're just gonna care about domain then, because range may not be that straightforward to find. And there are actually two cases to consider, and they are in examples number 5 and 6. So it turns out the two cases that I will care about are here. So in example number 5, we have function that is a fraction, divides 3 by some number, and it turns out we cannot divide by 0. Do you remember that? So that's a bad idea. We never divide by 0. Someone can say, Alex, are you sure? Well, you can check it. You can get a calculator. Remember, we can always check using that so-called scientific calculator. So I put this in my favorite Desmos calculator and try to divide 3 by 0 and see what's going to happen. The calculator doesn't like it. Well, simply because it's undefined, because there is no such a result. So we don't divide by 0. I say, what if I divide 0 by 3? Well, 0 you can divide by any number, but you cannot divide by 0. So if you divide 0 by 3, you get 0, which is fine, but you don't divide by 0. So I think it's good to realize, and it's being used when you are talking about domains. So you want to make sure that your denominator is not equal to 0. See, they looking at denominator and they say it's not 0. And that's why they throw away 0.5/2 from entire number line. So if there is an issue with domain, if the problem is at 0.5/2, well, then everything else is fine. There is no issues. And that's why they say, take anything but not 5/2. because it makes denominator equal to 0. That's why. So that's the first case. So you don't want to have your denominator ever be 0. And there is another case. The case when you extract square root. Let's say if you square root negative number, let's say -4. You say that's -2. No, you cannot square root negative numbers. Let me check this out. I put a square root, and if I try -4, again, it's undefined. I can square root +4, it's going to be 2, right? You can square root positive numbers, but not negatives. So that's another problem that we potentially encounter when looking for domain. So whatever is inside of your square root or so-called radicand, it's always greater than 0, and that's what they have here. They say there's also equal. Yeah, 0 could be inside of square root because the square root from 0 is 0, so that's fine, but not negative number. And then you solve inequality, and whatever the solution is, that's your domain. So that's what I will be concerned with in this section. So let us try to find some of these domains and ranges, and looks like this should be at the end. So I'm looking at the set of exercises here, and I'm going to look at the problems that like start at number 33. So that says in exercise 33, what about domain for a function? So this is section 3 of our review. So it's called R.3. What about domain of function 6 divided by 2 minus 6? Well, I see the case where we have denominator. So we don't divide by 0, remember? So we say denominator is never 0 when you're looking for domain. So what about x? Well, I can bring x over to the right side, so I can say x is not equal to 2. I say, Alex, you have 2 is not equal to x. Well, it doesn't matter. If 2 is not x, then x is not 2. You can write it from left to right or right to left. It still means the same thing. It says x is not 2. So what does this actually stand for? Is that point 2 is out and everything else is in. So what I did, I just pictured that on number line, well, to make my point a little bit more clear. Turns out there is a third way you can write down the same thing. So you can say from 2 all the way to the left to negative direction or minus infinity, or from 2 all the way to the right in positive direction, so all the way to the plus infinity. And people take a union of this. And you see, what is this? Couldn't you just say that x is not 2? Yeah, I think that'd be probably the shortest way to say it, because I just wrote the same thing 3 times. First, second, and third, they all mean the same thing. So it doesn't matter to me in which way you give the answer. I know they're all the same. So you like first or you like the last. Usually book uses the last, but either way is fine because they all mean the same thing. Exercise number 35. In the exercise number 35, we have another case. We have a square root from 2x. So if we have a function f of x, which is a square root, I want to make sure that radicand is not negative. In other words, to find your domain right away, you put the inequality. You say that 2x, that's what we square root, is not less than 0. It could be either greater or equal. And this brings me to dividing both sides by number 2, right? Because I always want to find x. So I divide both sides of this equation of this inequality by number 2 and end up with x being greater than or equal to 0. And that's it, that's my domain. So it's enough to just put this as inequality, and that's it. So we're looking for domain. Miss Alex, what about 37? In this exercise, we don't have denominator. In this exercise, we don't have a square root. Well, this will mean that in this exercise, we don't have a problem, which means that everything is fine. So what should I say? Everything is fine? No, you just say that domain is everything. And everything means all the real numbers. So you're not throwing away anything from real number line. So if there is no denominator, if there is no square root, then all numbers are good. All numbers work. And that feels pretty good. That's all it is. So 2 cases, either square root or denominator. Let me try one more, and then maybe you can try one for a little quiz. Exercise number 49. It says divide 2x by x squared minus 25. Well, right away I notice that this is a fraction, right? So in this case, for my function g of x, I say that denominator is not equal to 0, right? That's what I need to make sure that we do not divide by 0. It's not allowed. Okay, so what will be my domain for this function? Well, I need to solve this equation. I say that's like inequality. And they give a hint. Factor x squared minus 25. Well, you can factor it with x minus 5 and x plus 5, right? Did you ever see this before? The factoring? So indeed, 5 is what concerns. So because x equals to 5 is no good. Because if 5 you square, you get 25 minus 25 is 0. But you see there is one more. Yes, it's also minus 5. Because if you replaced x with a negative 5 right in the second piece, right? And here was negative 5. It's going to be 0, minus 5 plus 5. So that's the problem. So what I can say, just 2 numbers are out, plus and minus 5. Everything else is in. Everything else is in domain. So just making sure that we don't divide by 0. I say, Alex, what about 52? That's a square root. What about the domain for number 52? Well, there is no denominator. There is no square root. All reals, all real numbers. See, you don't have any problem here. I know it looks a square root, but so what? You have an absolute value. It's not a square root, it's not denominator. So you don't have any problem, which means that all numbers work, all numbers are good. So domain is everything. Everything on the x-axis called real numbers, because x-axis is the real number line. So all reals work for domain. So how about if you try one exercise in here? How about problem number 34? for today's quiz. Problem number 34 is asking you about domain, just like we did in the previous exercises. So look at exercises like I just did here, 49, because it has denominator, right? So please let me know, what is domain? And I say, how can I? Well, you can say what it is not equal to, because everything else will be in your domain then, right? So just put your answer in the Zoom chat. Remember how to answer a quiz. You should tell me this answer, but please don't hurry. You want to send it to me, only to me, not to the whole class. Because if you send the wrong answer to the whole class, well, maybe next time you get in trouble because you tricked everybody. So you want to just don't hurry. I give you plenty of time. So you don't want to hurry. You want to make sure that you send it only to Alex, please. So don't hurry. And then after you are done, you can log out and enjoy the rest of the day, because we're going to continue on Friday. So on Friday, we're going to actually have our last Zoom meeting. And then next week, I'll be back to the classroom, but it's going to happen on Wednesday next week. Did you know that? The reason is Monday is holiday. You have a long weekend coming. Monday, there are no classes. The school is closed. So you just stay home and enjoy Monday. So there'll be no classes anywhere in the United States. The holiday. It's Martin Luther King birthday, so all schools are closed. So you can be done with the quiz and then log out and enjoy the rest of the day, and we'll continue with this story on Monday. So yeah, you can leave, but make sure you give the answer to the quiz before you leave, right? Bye-bye. Have a great day.